Any doubt, difficulty in the content which we learned last lecture? Before we move on, if there is need to be explained again, I can do it. So application, the divisibility test we are using to figure out whether the number is perfect, can be perfect square or not.
Divisibility find the answer of that question for the charge of the
I think
reverse way around. So negative test.
oh.
If I'm given this question and asked to find the answer.
So you apply divisibility test of 4, and if the remainder is 2 or 3, then you say it is not a perfect square. But suppose you get it as a perfect square. Maybe you try divisibility test of 3, and if the remainder is 2, then it is not a perfect square. And suppose in that test also, if you cannot catch the number, then maybe you can apply 9 or something, or prime factorization. Yes. So it is a negative test. It does not guarantee that the given number is a perfect square. Even if the number passes divisibility test of 4 or divisibility test of 3, still, and we can develop similar divisibility test of 9 also, because there will be 9 different remainders. If we apply divisibility test of 9, and still we will get some idea over there whether should we deny this number from being perfect square or not. Okay. So it is not a test to identify the number whether it is perfect square or not. It is the test to figure out whether it is not perfect square or not. Maybe that is correct. It is the test to identify whether the given number can be a perfect square or not. Illegitimate. Okay. अजून एक काहीतरी डाऊट होता. हा मॅडम तुम्हीच विचारा.
Sir,
Yes.
sorry. There was a doubt with the PDF shared in the 10th question of that PDF.
There
The
are more than one answers. Is that the question? 6?
हा बरोबर.
Mr. Ram.
कारण हा त्याचं एकच उत्तर दिलंय त्याच्यात, तर मला असं कळलं नाही की मग
Yes, you are right. Input conditions थोड्या better पाहिजे होत्या. त्या नाहीयेत, त्यामुळे there are more than one answers. Correct.
Okay. Yeah.
If we take 580, then 31,581.
Okay.
Start like that 10,000 plus 1 minus 1.
Yes.
Then first number itself is not divisible by 11. So what we want the number in the format like say 311 into 7 like that. In the first place itself it is not divisible by 11.
Yes. So if that number is not divisible by 11, then we should subtract and check whether that number is divisible by 11. Either 10 raised to k plus 1 will be divisible by 11, or 10 raised to k minus 1 will be divisible by 11. That is
depending on number of digits, please first take 9 or 1.
Yes. Yes. So, but the question was good. I mean, we have done the example even digits, and there were 3 minus remaining 3. We could do it. But suppose the number is odd digited number, then what do we do?
First take 9.
1, 3, 5 you add, 2 and 4 you add, and then subtract. Alternate digit we have to add and subtract even digited numbers, even place numbers, and sum of odd place numbers. Subtract and find out whether the remainder is divisible by 11 or not, and that will work. कशाला तुमच्या म्हणजे आता फॉर एक्झाम्पल 1000 जर असेल मल्टिप्लाय 1000 प्लेस वाला जो डिजिट असेल तर 1001 इज अ गुड नंबर फॉर अस. But if it is 100, then 101 is not, because 101 is not divisible by 11. Then we should go for 90. 90. So either +1 or -1, definitely you will get one of them as divisible by 11.
And that square test that doesn't have much meaning on the speech. Suppose we take number 4086, then
4086.
then 36 means this can be perfect square. Remainder is
This may be perfect square, this may not be.
actually factorially it is not perfect.
But
Only it can be, that is not.
yeah, it may be. Maybe it is a perfect square or not. You will have to find out some additional method of checking whether it is perfect square or not. This particular divisibility test of 4 is not giving you any information. Negative things. Okay. So let us begin. Yes, Rashmi madam, अजून काय विचारायचं तुम्हाला?
Nice, sir. That's it. Thank you.
We will begin with geometry.
सर मला एक डाऊट आहे.
Ah,
सर आपण डिव्हिजिबिलिटी टेस्ट वेगवेगळ्या नंबरच्या ज्या बघितल्या त्याच्यामध्ये आपण टेबलमध्ये निगेटिव्ह टेस्ट आणि पॉझिटिव्ह टेस्ट, सो आपण 1 जिथे येतो तिथे थांबतो, 9 जिथे येतो तिथे थांबतो, हे कशावरून ठरवलं आपण?
कारण आपण डिव्हिजिबिलिटी टेस्ट स्वतः डिझाइन नाही केली, आपण
बरोबर.
डिव्हिजिबिलिटी टेस्ट जी होती त्याला डिकोड केलं.
ओके ओके ठीक. सो इट इज अ शॉर्टकट टू फाइंड द नंबर्स टू फॉर ऍडिंग अँड सबट्रॅक्टिंग टेस्ट, ऍडिशन अँड सबट्रॅक्टिंग मेथड.
It is a trick. It is an algorithm which we are cross-checking and finding out why it is working. For finding out such algorithm, I mean, you need to be genius.
ओके थँक्यू सर.
Okay. I mean, in first lecture we have done some geometry, sum of interior angles of triangle 180, and then we have deduced 180 into the n-2 for sum of interior angles of convex polygon n-sided, and sum of exterior angles equal to 160 always. Then vertex opposite angles are equal, angles forming linear pair are equal, are 180, and then exterior angle of triangle is always greater than remote interior angle, and so on. We have done some theorems at that time. So now we will get into details of geometry, because majority of your question paper is on geometry. Therefore, we have to do some work there. We will begin with triangles, and the lecture note that I will send you after today's lecture will have first few pages where the vocabulary is developed. That means triangle has got 3 vertices A, B, C. Then it will have 3 sides A, B, B, C, C, A. Then we will call angle A is included between AB and AC. Side AB is included in angle A and angle B. Something like this, which you can read and understand. It is very easy. That is how we talk about triangles and their properties. So essentially, the first thing that we need to learn in geometry is congruency of triangles. Congruency. 2 triangles will be congruent. They will be exactly looking alike. And then what should be the difference? So that we say the given 2 triangles are congruent. So we need to first define definition of congruency of triangles. एकरूपता, त्रिकोणाची एकरूपता. 2 त्रिकोण एकरूप आहे तसा आपण केव्हा म्हणायचं? When do we say triangle ABC is congruent to triangle PQR? Okay. Definitions are made for development of language in mathematics. If we are making definitions in mathematics, and then if I use word congruency, all those who are learning congruency of triangles will understand what I mean. I need not have to keep explaining every time. Therefore, congruency is important word for us, but we have not dealt with it earlier. Maybe we know English meaning, but what do we mean by mathematical meaning of congruency? That we want to explain in very simple manner, very easy to understand, very easy to remember, and definitions are always if and only if. If and only if is very important word in mathematics, where if x then y, and if y then x. So you can go in one direction and you can come back in other direction also. That is, these statements are called if and only if statements. The condition which is necessary is also sufficient. The playground is wet. It must have rained. So rain, it has rained. If it has rained, then the playground is wet. This statement is true. But playground is wet implies it must have rained. Maybe it is false. So in maths, there will be many theorems which will work in both ways. We will call the first one as a theorem and the other one as a converse. However, definitions are always if and only. If I say that these things, if they happen, then I will call triangles congruent. Which means, if I tell you that these two triangles are congruent, that means all those things must happen. So, definitions are always if and only. Very important. So you will find if and only if word in many places in mathematics, and the meaning is this way: if then, if x then y, and simultaneously if y then x. If both of them are true, then the theorem and its converse both are true. Okay, definition. What should happen if I want to say that these two triangles are congruent? दोन त्रिकोण एकरूप आहेत असं मला समजा म्हणायचं असेल तर काय कंडिशन टाकूया?
Sides are equal on the
Measurement of sides are equal.
काय मेजरमेंट काय?
Of sides is
Corresponding
equal.
should be equal.
So their angles and lengths
all
are
angles.
equal.
All
All
angles
angles and lengths are
should
equal.
be same.
आवाज कमी करूया आपण ऑफलाईन वाल्यांना काय बोलायलाच देत नाही तुम्ही एवढे ते लांबून येतात इथे क्लासरूम मध्ये आणि बोलताय तुम्ही सगळे जोरात. बरं ठीक आहे. हा थांबा ऑनलाईन थांबा तुम्ही सांगा. When do we say two triangles congruent? हा बोला.
Angle test or angle side angle test or side test.
जास्ती थोडंसं घर्षण झालेलं आहे. आता मी त्या लेवलला नाहीच आहे.
triangle
May I, sir?
These two triangles are congruent.
ABC.
Huh?
Triangle P.
Sir, their corresponding
Corresponding
हा.
sides and corresponding angles are congruent.
Yes. Good.
If they superimpose each
One
other.
hide the other completely each other, then they are congruent.
What completely what?
If one triangle can hide the other one completely,
Okay. But now they will not hide because they are sitting one after the other.
Sir, if all the three sides and vertices of one triangle coincides exactly with the other triangle, then we say that it is congruent.
Put this and put on that. Then only we will be able to say they coincide. And so maybe coincide is difficult. Na? Practically craft work करायला गेलं आणि आता तर म्हणजे electronic board we just cannot do anything. And then even if we cut this and paste over here, we may make mistake in checking whether they are aligning or not. Right? If we- So
only when their corresponding angles are same.
they must be mathematical, less English, more maths. And if it is a definition, then it has to be understood by everyone very, very easily. Not very difficult words, simple. So let us, I mean, any triangle has got 3 angles and 3 sides. So if statement number 1, major angle A equals major angle B. Statement number 2, major angle B equals major angle Q. Statement number 3, major angle C equals major angle R. 4, length of AB equals length of PQ. Now, this is universal. I mean, this is worldwide notation. If I write AB, it means length of segment A. 5, length of segment BC is equal to length of segment QR. And 6, length of segment CA equals length of segment RP. These 6 conditions. If these 6 conditions are true, if let me remove this A and write if and only triangle ABC congruent triangle PQR. So this is a shortcut for if and only if. I double F. So if this is given to me, I can go from this side to this side and say that these 2 triangles are congruent. Suppose tomorrow I give you this, then you will be able to come back and say all these 6 elements must be correspondingly equal. Okay. Now, last lecture, sometime I have explained. I can take angle A and angle P here, technically correct, but I have to write congruency side there. Here I cannot write triangle ABC is equal to triangle PQR. Triangle ABC will be congruent to triangle PQR. Here, angle A is congruent to angle P, looking alike. But if we measure, then this is a real number which is equal to another real number. Clear? So I have used equal to in LHS, left hand side, and congruency sign in right hand side. Clear? Okay, now let us come and talk about. So I have basically 3 angles and 3 sides. Okay, so if we get a triangle whose all these 6 elements are correspondingly equal, then by definition these 2 triangles will become. Yes or no? But then checking all 6 elements is time consuming, inefficient. Maybe we did not have to check all. Maybe we can check only 5 and do away with that. Maybe we can check only 4 out of the 6 and do away with that. Maybe we can check only 3 half of that, half of the total. And still we may be able to confidently say that triangles are congruent. Correct? And therefore, we call them as efficiency criteria, or we call them as test of congruency, etc. But what we want to do is, we don't want to spend time in checking all 6. Maybe in some circumstances we will not be able to check also. The limited information is available with us, we can check at most 3, at most 4. Sometimes the information about only 2 is available. So if information about less than 6 is available, still can we say that these 2 triangles are congruent or not? If yes, then we will call that as a test of congruence. If no, we will not say anything about it. So it is our responsibility to find out Of course, if all 6 elements are given, then job done. By definition, then these two triangles will be congruent. 5 is also a lot of information. Therefore, with 5 also it will be done. With 4 also it will be done. And then therefore we come to minimum how many you are in the need of. So that you say 2 triangles are congruent and minimum are 3. And then we have information about 3 minimum. Then we may be able to say that these 2 triangles are congruent. And if the information is not good, even if it is 3 out of 6 things are given to you, maybe still we will not be able to say that triangles are congruent. So let us find out how many ways we can get this information if we decide that minimum 3 things are required. Let us say all 3 sides are given and all 3 angles are not given. Then 1 angle and 2 sides. It can be done in these 3 ways. Why? Because when I say SAS, angle is between 2 sides. Here angle is between 2 sides. In SSA, do you understand? Angle is in that, given information is that sequence. If it is, of course, ASS and SAA is okay, same. ASS. So they are one and the same. But just for listing, we are listing. So only one information about angle is available and 2 sides. So these are the 4 ways of doing it. Then we have 2 angles. SAA, ASA, AAS, and then all 3 angles. AAA. These are 8 different ways of finding using 8 different ways of choosing 3 out of 6 that we have. बरोबर. मग समजा या सगळ्याच्या सगळ्यांनी जर आपल्याला if they provide all the information about both the triangles and both the triangles are fixed by getting this information, then there would be 8 congruency tests, but we can say that this and this is same, this and this is same, therefore 2 less than 8. There will be 6 tests of congruency eventually. But they are not. There are total 5 tests of congruency, and let me just circle them. In textbook, you will find SSS, test of congruence, SAS, test of congruence, SAA, let us pick this, which means this is also there, and ASA. Here we can find that there are only 4, and as a special case, there is 1 more 5th. So out of 8 possible combinations, we have only 4 combinations which will give us every time exactly same triangle. No matter who draws it, no matter where he draws, no matter which tools you use, triangles drawn by that information in everybody's notebooks will look alike. No need to check also. Say for example, all 3 sides are given. If all 3 sides are given, then everybody will draw exactly same triangle. Now we don't get into details. So suppose side ABBCCA is given. AB is given say 5 centimeters, BC is given say 6 centimeters, and CA is given say 7 centimeters. Can we draw a triangle and will it be unique? For 7, 8 standard students, this is good enough. But then what is theory saying, I will tell you later. So how do we draw this triangle? Suppose ABBCCA. Apply. कोणतरी सांगा मला कसं काढू ट्रायंगल? Suppose centimeter. हा सांगा. AB काढू आधी. So draw AB. AB 5 centimeters. Then take compass, measure 6 centimeters in the compass. Put the steel point on B and draw an arc at distance 6. This is first locus of point C. C is going to lie on the circle which is of radius 6 and center B. Sir? So this is first locus. नाही. Okay, then भरपूर झाले, infinitely many seeds झाले इथे. So how do we fix? Similarly, take 7 centimeter distance in compass, put the still point on A and draw a circle, cut an arc. Wherever they meet, they intersect, it is going to be a unique point. Not unique, you can get one more here, 2 points. But suppose we have got 1 point, then this is the point which is 6 centimeters away from B and 7 centimeters away from A. Therefore, this is our eligible point and we get triangle ABC, and everybody following this procedure will get exactly same thing. Now, suppose somebody starts with BC, this side, that is fine. I mean, you can rotate and adjust. It is one and the same. You are not going to get a different looking triangle by using this information. Therefore, this is efficiency criteria. You have used only 3 out of 6 properties of triangle, characteristics of triangle, and we predicted that if I draw ABC with this, and if I draw PQR also with this, then these 2 triangles are bound to be congruent by SSS test. SSS test. And there is no way that we can get some other looking, different looking triangle using same information, not possible. Therefore, SSS is a test of congruence. Now, SSS is a test of congruence, is good enough for 7th and 8th, but SSS is a theorem which is required to be proved rigorously. At this stage, this is good enough. Okay. Okay, so SSS is there. Then SAS. For SAS, I will have to give you some information. काय information SAS angle side AB is equal to 6, angle B, major angle B is equal to 30, and side BC is equal to 7. Suppose we give it like this. Then everybody will draw exactly same triangle. Yes, you will start with BC or AB. So let us start with BC, 7 centimeters. Using your protractor, you can draw angle B at 30 degree. So this is first locus of point C. Point A. A will lie on that line. And then we want another locus to fix point A. Take radius 6, till point of B. This is 7. Then cut here. Join. This is here. So it seems SAS is also going to work as test of congruence. Barabar, right? No issue. Then let us start ASA. Angle B is equal to 30. BC is equal to 7. Angle C is equal to 45. Can we complete? Draw BC 7 centimeter. Draw angle B 30 degree. And draw angle C. You have point B with you. You have point C with you. Draw angle C 45. Okay. Straight line into straight line first locus, straight line second locus. Here, straight line first locus, circle second locus. Here, both the loci circles. That is important. Therefore, that point is A. So yes, ASA is also a test of congruence. Now, without doing anything, we can declare that SAA is a test of congruence. Why? Without doing anything, we can declare that SAA is a test of congruence.
equivalent to 8 is 8 because 2 angles are given, so first angle we can find.
We have done in our first lecture that sum of interior angles of triangle is 180, out of which 2 angles are given to us. Therefore, with using algebra, we can find out the third angle and apply ASA. Again, because ASA is a test of congruence, SAA is a test of congruence. But then let us learn how to draw. Measure angle BC is equal to 7, and measure angle C is equal to 45, and measure angle A is equal to 70. Tell me, how are you going to draw this? Draw BC first. Online. Sanga, how do we draw this triangle with this information?
Sir, we first find the measure of angle B.
Draw line segment BC of 7 centimeters.
Draw line BC7.
Then, with the help of protractor, we will draw a ray
45.
with an angle of 45 degrees at C.
Yes.
Then draw another ray which makes an angle of 70 degrees at no sir, sorry, angle is not given. We have to find the angle A first. By the help of angle A and C, we have to find angle B first. Then we will proceed this.
So 180 minus 45 plus 70. कितने रहे? 70 60.
155.
So this is not correct. You can keep moving your protector and check whether when it is passing through B and it will never pass.
Sir,
Ah.
can we draw first AB line segment AB?
Not given. AB is not given. BC is
Is not
given.
given.
We cannot draw AB because AB is not given. They have been given this. So this is the idea. You find out the remaining angle and use the same procedure of ASA. And because of our first lecture, we will automatically get this 70. And this is the point. Good. So why are we considering it as a test? Because we save time. Because we know it is going to work. And every time we did not have to write that therefore third angle is this and using ASA, our triangles are congruent. No, we give permission for SAA or AAS to be test of congruence. No issue. Okay. So now remaining essentially, this is also done. Because this and this is saved. So what is remaining is essentially 2 AAA and SSA. So if I give you information about triangle, measure angle A is 70, measure angle B is 65, measure angle C is equal to 45. Will you all get the same triangle in your notebook if you draw like this?
No sir.
No,
We can
sir. No.
Sir,
Why not?
Infinite.
length
There can
can
be
Because,
infinite number of triangles.
Why?
Because we can draw length of any measure.
Because any one of the length is not given, we can draw the triangle starting with whatever BC you want and then creating those two angles. Actually, 3 angles are also not required, only 2 angles are required for drawing triangle because third we can anyway find out. So the third information which is given, is useless, and in fact we are getting only 2 things out of 6, and therefore getting congruent triangle is almost impossible. Okay, and you are right, we will get similar triangles but not same triangle. We will get similar triangles but not congruent. Good. So therefore that logic is also justified. Now tell me whether SSA is a test of congruence or not. If yes, why? And if no, why? So if you want, I can give you some information. Maybe you don't have compost box, but you can assume that you have it and start drawing. So wait, let me give you information. measure angle B is equal to 30. BC, I have to give it S A form. Instead of AC, so that AC is equal to 5 and BC is equal to 7. And angle B A S X. Now, ASS or SAA. Can you draw this? Is it 7? Is it 5? And angle B is 30. We should be able to draw.
Sir, can we draw the line segment BC and then angle B, and by using the that rounder we can draw the from like C point, we can cut out the A.
Yes.
We don't have the angle C,
Those
so
who
we
are teachers actually teaching maths right now, 7, 8 standard. Can you tell me whether this is a test or not?
it is not a test, sir.
Huh?
It is not the test of congruency. We can't draw the triangle with this information.
Mukesh sir is saying that this is not a test of congruence. However, when we draw, we get the triangles. Is it true?
We can't draw, sir, with this information.
Why? Why you cannot draw?
If we draw
Everybody else is actually showing. Let me also try. Let BC be 7. BC is 7. Angle B is 30. So we are looking for vertex. Angle B is 30. And third information is
Then AC 5. AC. From C
AC
we
is
can
5. We have C and we have AC. Yes or no?
There will be 2 points under the ring with AC.
Now let us follow the procedure. Let us take 5 centimeters in the compass, put the still point at C and draw an arc of 5 centimeters. And now, yeah, all these points are centimeters away from C. Therefore, we got one triangle, obtuse looking triangle.
पुढे जायचं ते सांगत बसणार का तोंडाने करा मला एवढ्या
Match will tell. Given with the same information, you end up having more than one triangles. And therefore, SSA is not the test of congruence. Or ASS is not the test of congruence. Now, everywhere, why there are 5 tests of congruences are there? I mean, why nobody will teach? Which 5 tests are there? Is there in every board syllabus? And there will be quite a few problems on that if students will solve, but nowhere in any textbook it will be discussed why AA is not the test of congruence and why SSA is not the test of congruence. Now, I remember, I think 2013 or 14, IIT Advance had this question. They had given this information 7, 5, and 30. And they had asked students to find out area of this triangle. So out of 15 lakh students, only 50,000 students will be aware that there exists a triangle like this. All others will say the area is 0 because both the triangles are congruent. There is no such area produced. A1 and A2, no distinct points, they are coincident. Therefore, area is 0. Okay, only those students who will know why the SSA test of congruence is not there will be able to visualize that there exists a triangle and it will have some area. Finding this area, if this is 30, it's very easy. So it is very easy problem, provided you have that information that SSA is not a test of congruence, which is not part of any syllabus, nobody will teach.
Sir, what was that question, sir? Could you just repeat? Like that hash triangle.
In IIT, they have asked using this information, get the triangle and find the difference in area of all possible triangles.
Okay, sir. Thank you. I got it now. Thank you.
Okay. But then there is additional test in textbook, RHS, right angle, hypotenuse, and side. So if the triangle is right angle triangle, and if you are given hypotenuse length, say 10, if you are given one of the two sides, say 7, and if you are given one of the angles equal to 90, then they say, yes, it is a test of congruence. If you draw a triangle like this, you will get congruent triangle. But then the information supplied is SSA, side angle, which we just denied, that SSA cannot be test of congruence. And the fifth test which they have put is SSA.
Because in this triangle, sir, in right angle triangle, there is a Pythagoras theorem by which we can get third side with the help of two sides.
But we don't know what Pythagoras theorem means. I mean, we can do Pythagoras theorem provided we have congruency test.
Sorry, sir. Can you repeat, please?
Yes. We don't know what Pythagoras theorem means because in last 4 lectures, this is 4, we have not learned anything. Pythagoras is very difficult. What we have learned is sum total of internal angle is 180. And today we are learning what do we mean by congruency, out of which we have found out there are 4 tests and fifth test is in trouble. So there is no question that we have some tool which we have developed to find out this side and use SSS. Is it clear? People have done it earlier, therefore we can use. But suppose we are starting from scratch, the first person who is doing this will not have Pythagoras. He will have only congruency.
Sir, as there is right angle triangle, there will not be triangles with obtuse and acute angles.
There will not be what?
There will not be 2 triangles, no? There will be only one and only with right angle triangle.
Yeah, but then that we can anyway say without getting into these details, because it is test of congruence, and several years when we were young, when we were in school, it was test of congruence. Maybe when our earlier generations were studying, it was test of congruence. Therefore, RHS must be a test of congruence, and you will not get second triangle. You all of us will get exactly same triangle, and it will work. Because it is test of triangle and congruency. Our forefathers must have done it correctly, na? Why will they make mistake? They have done it correctly. Therefore, RHS is there, and therefore it is congruent, and you will not get any other triangle. But now the question is, we have just now denied for SAS. We have denied. We have denied SAS. And this is not the test of congruence. Cross. We are saying this and this is same, they are not the test of hope. And suddenly we are saying, no. Special case. We have SSA, where it is right angle. Yes, it is test of hope. How can we do that? Not correct. The correct answer is, of course, the same answer. Now, if we start producing this triangle, suppose we start producing this triangle, suppose we start drawing this triangle, how will you draw? There are two ways. You can start with hypotenuse and complete the right angle triangle, or you can start, easier way is to start with side. So, just for the sake of simplicity, let me start with ABC. So, I draw AB 7 centimeters. Then I draw 90 degree, right angle. Okay, 90 degree I can draw. So C lies on that particular ray somewhere. And then I take compass, put the still point on A, and take the radius equal to 10 and draw an arc. Oh, I wanted that this arc cuts this line at two places, but it is not. It is cutting at only one place. This procedure I wanted to follow. Draw the arc, complete arc or complete circle, but unfortunately, that arc does not intersect at two different places. Therefore, every time you will get a triangle, which is going to be unique, and hence RHS is the test of congruence. Yes, special case. Because this angle was good enough, 90 degree, it is ensuring that the double cut is not there. There is one more test of congruence actually, which is not there in the textbooks. S1, S2A. Side 1, side 2, A. And A. S1 is greater than S2. If S1 is bigger than S2, then you won't get that cut. And therefore, S1, S2A is a test of congruence under special circumstances where S2 is greater than S1, and in our right angle triangle, hypotenuse is always greater than the side. Therefore, it works. So, there are involved problems or difficult problems where you are supposed to use congruency to show two triangles congruent. But none of these 5 tests which we have done earlier will work there. Maybe that problem is designed on this test. So it is going to be extremely difficult. Majority of the people won't know this test, and therefore they will not be able to crack that problem. S1, S2A is a test of congruence, provided S1 is greater than S2.
But sir, then why didn't that thing work? BC equals to 7, AC equals to 5. There also we have one side greater than. So in the previous example where we have that shaded region as possibility of two triangles with the
Yes,
same
our
configuration.
S1 was 5, S2 was 7, and angle was 30. So S1 was lesser than S2.
So how do we
Therefore, we are
determine
getting
which is
double cut.
7, 5, 30. Is it possible, sir?
Huh?
7, 5 and 30 degree. We can see like that only, no?
7 this side. 7,
Yes.
5 and 30. I think so. Yes, we start with.
Yeah, that is what I was asking, sir, that why can't we consider 7 as S1 and then it has the same principle? But we know that it didn't work. I'm just asking why it didn't work in this case.
Then what we should do is take these rectangular numbers, S1 smaller than S2, S1 is equal to S2, S1 greater than S2, take some angle 30, 45, whatever you want, and keep drawing different pictures and say, check whether you get two triangles or one triangle. Every time S1 is greater than S2, you will get one triangle. Every time S1 is less than S2, you will get two triangles.
S1 is the first side that we are drawing. In the previous example, sir drew the S1 as 7.
It is not the side which we are drawing first. No. See, information is given in
The angle outside the
SSA form. Information is given in SSA form. So A is the last. So 30 degree is the last. Then immediate next to A is S. So 7. And then S1, which is 5. 5, 7, 30 is important. We just cannot flip 7 and 5. If we flip 7 and 5, if this is 7 and this is 5, of course you will get one triangle. And then see, unless and until you take compass, draw, sketch, you will not understand. I am telling you what is correct. Okay? And it is going to be correct because that is how the theory is. We are not allowed to flip these two sides here because that sequence is important. It must be SSA.
That means, sir,
Here it is
you
stated.
saying the side near the angle must be. So are you saying the
Side
side
near the angle must be this
other
S2
S2? Huh?
and away from angle or maybe opposite to angle is S1. Opposite to angle is S1.
Sir, will you please write SSA in terms of sides and angles? SSA, please write it in terms of sides and angles once for all.
AC, AB, B. Is this what you want?
Sir, can we say S2 should be the arm of the angle B or whatever?
So in short, what we are saying is that if two sides and the angles extended between those two sides is given, then only we can say it's a test of convergence. If otherwise, it will create a redundancy or multiple options.
Yes, but then if S1 is greater than S2, it will not be.
This happens only when the angle is 90 degrees, right? S1 is greater than S2.
No, if it is obtuse angle also, it will happen. Suppose we draw AB, and then if we draw BC, this way. Then of course the side opposite to obtuse is supposed to be bigger than this side, and therefore we take an arc. It is not going to that. 90 is actually the boundary. If it is acute and if your lengths are such, but then it's okay. So far this is bigger than this. This angle is going to be smaller than this because of advanced theorems that eventually we will prove. But at the moment, if the S1 is now side opposite to given angle must be bigger than the other side which is given. As simple as that. So if it is suppose ASS, then we call this as S1 and this S2, then S2 must be greater than S1. But then I mean, we just don't create confusion, we write it as SSA.
Excuse me, sir.
Yes.
Tell me how we will decide which one would be S1 and which one will be the S2. Is
How
there
will
any
we
condition?
decide? How will we decide?
Side 1 and side 2, S1, S2.
Yeah, the given angle, if the angle is given, then side opposite to that angle is S1. If you are using this notation, SSA, if we are using notation SSA, then S1 is side opposite to angle given. And S2 is remaining one of the two sides.
It means side 1 should be greater than side 2 now.
Yes.
Okay, sir.
Maybe even 7.
Extremely sorry, sir, but I want more explanation because confusion is there.
So, opposite to given angle, side is bigger, but still, I don't think you can draw the fixed.
Wait, I will come back to it.
Opposite side should be smaller.
Wait a minute. Madam,
AB is 7,
AB is 7. AB is 7.
AC is 5,
AC is 5. Which angle you are giving?
and angle C is given at 70.
7. Angle C is 70.
Side of
Okay. AB is 7. AC is
5.
5. And
Angle C is 70.
17 degree.
70, 70.
70. Okay. So how do we start? We start with AC. Okay, AC 5 centimeters. At C we make angle 70 degree. Sorry, 70 degree. And then put compass on A, and AB is greater and set 5. So your circle will go like this. It is not going to intersect AC again because AC is smaller than AB. Circle is going to be bigger. So the entire segment will be inside that circle. Yes. So what was the question? Unlike.
Sir, it will be the unit triangle, na? So we can apply SSA.
No, I have a request. Why don't you start your video first? What is the problem in starting video?
Yes, sir.
Yes, then learning will be better. Okay. So SSA is a test of congruence provided S1 is greater than S2, S1 is side opposite to angle A. S1 is side opposite to given angle.
Okay, sir.
Yes. See, the moment camera is on, everything is clear. Sir, so we have got our congruency test with us. Any other doubt, difficulty, question? How do you solve the problem PDF? How do you solve the area problem? Area problem in a IIT exam. Now, there is a theorem that side opposite to 30 degree, draw perpendicular here, draw perpendicular. This is isosceles triangle. This is also 5, this is also 5. And if you draw perpendicular, then it is going to make 2 equal parts. And side opposite to 30 is half of hypotenuse. This is right angle triangle. So if this is 7, then the height is 3.5. Height is 3.5. And both the sides available. Right angle triangle 5 3.5. I can draw this much. Find out Pythagoras. 5 3.5. I can find this much. So base is known, height is known, area. But students know trigonometry, so they do it very quickly. Okay. Let us look at applications. Okay, let me list. So test of congruence. One. SAS. Let us write SAS as a first test because SAS test is considered to be postulate. True without proof. Don't ask questions. Why it is true. And last, this is done by Euclid in 2000 years before, and he has assumed that SAS as a postulate, and till date it is postulate. And if SAS is assumed to be postulate, then we can prove this is postulate. 2 SSS theorem. 3 ASA theorem. 4 SAA theorem. 5 RHS. Yeah. So these are theorems. We can deduce all the remaining 4 tests using SAS postulate. We can prove them. We are not going to do it in class. Those who are really interested can be supplied with the proofs. Okay. Now, what do we mean by this? Let me write down one test very clearly, and all the tests will go exactly like that. So let me write SAS. So, sorry. Consider
Sorry sir, the RHS चं लॉंग फॉर्म काय म्हटलं तुम्ही?
right angle hypotenuse side.
Thank you.
Consider ABC corresponds to PQR. This is where we are deciding the notation which corresponds to. Hello.
So this RHS, why RHS is mentioned when that S1?
Now S1, S2A, if we allow school level, then there will be a lot of confusion. And they will start using SSA test everywhere without understanding the situation. Therefore, it is kept aside. And only right angle triangle is easy, I mean, special triangle. Therefore, it is easy. Therefore, they have supplied with RHS. Because we have got sufficient confusion here, right? When the group is very small. If it is given to 15 lakh students in the country, then there will be a lot of confusion. Okay. Now here what we are trying to set up is, when we say ABC corresponds to PQR, I mean you have to compare A with P, you have to compare B with Q, and you have to compare C with R, side AB with side PQ, side BC with side QR, and side CA with side RP. This and this is not same. It is different. Side, I mean ABC corresponds to RQP is a different correspondence than ABC corresponds to PQR. Okay, so we should be clear about which two triangles we are considering and are they congruent or not. We will find out. Yes. One. Now given the condition. One. SAS we are writing. AB segment AB. Now notation is this. AB bar is congruent with PQ bar. 2. Angle B congruent angle Q. 3. BC congruent QR. Wow, this is given. If these three things are given, I have to write if 1, 2, 3, then for triangle ABC it's congruent triangle PQR. Now everywhere we are supposed to write the reason why it is true. Here the reason is given. Here the reason is given. Given. Therefore, we say that triangle ABC is congruent to triangle PQR by SAS test. Then we deduce. Now, why this is interesting is we have out of 6 we have used only 3, and we have got 2 triangles congruent. So, if and only if definition of congruency will give us remaining 3 things are also congruent. That is the deduction. We deduce that 5 angle A is congruent to angle P corresponding angle
corresponding angles of congruent triangle.
of congruent
Triangle.
triangle.
CACT.
What should we write? CACT.
CACT.
That is the fifth thing, I mean, first thing that we could reduce. Second, 6. Okay, we have used side AB, BC, CA. Corresponding side
Corresponding
of
sides of
congruent
congruent triangle.
7 angle C is congruent to angle R. C,
Yes.
A, C. This is the complete correct statement of the theorem.
Sir, what is CACT and CACP?
Corresponding angles, angle of congruent, corresponding angle of congruent trend. CSC, corresponding side
Okay. Okay, understood.
trend.
Can we use C in place of CSCT and CACT?
Yes.
Can we use CPCT?
CPCD. Okay, corresponding parts of congruent.
And sir, while proving the two triangles are congruent, we have to write a line segment AB congruent line segment PQ, or we can write simply AB equals to PQ.
Here?
Yes, sir.
Yeah, you can write AB is equal to PQ also.
Okay, sir.
It's also segment signing things by.
वरती पाहिजे ना? Yes.
CPCT is what?
Parts. Instead of CS and CA, CP. So you need not write angle or side, you can say part of congruent.
Okay.
Like this, we will have the statements of all the congruence tests. All 5 we can write it like this. So this is the technically correct statement of the theorem. It is there in the lecture notes that I will supply you. Everything is written in detail and in very nice. So now let us really start enjoying the congruency test to prove few things. In triangle ABC, if B is equal to AC, then major angle B equals major angle C. Isosceles triangle. AB is equal to AC. So if triangle is isosceles, corresponding opposite angles are also equal. Yes or no? Yes. We know this. But
Yes.
now it is time to prove why it is true. Now, when I say you have to write down the solution or answer in triangle ABC, if this, then that, then we are expected to write something like this as a solution of this problem. Maybe because this is first problem to be proved and proof is to be written, which I cannot check. Let me try writing it for the first time for you, and after this I will not. We will solve at least 5, 6, 10 problems in class, where every time you are supposed to write. But how to write, I need to show you. Therefore, let me write the proof of this. Is it okay, or you want to try it on your own? What about that?
What we will construct a perpendicular on the base of isosceles triangle.
What?
We will construct a perpendicular on the
No, I am
base.
not asking solution. I am not asking solution. I am asking, should I show you how to complete the proof? There will be more than one ways of doing the same proof. More than one ways. Of doing
Yes, sir, please.
But this is isosceles triangle.
So that is what I am saying. I will write the first, then you can try the subsequent problems or maybe alternate proof of this. Okay. Now, proof. I have this in and I will start with let M be midpoint of B. Okay. Now the question can be asked, if suppose there is no midpoint. Yes, we have to discuss and prove that every segment will have unique midpoint. We have to prove that. But we are not getting into that details. We will assume that there exists a midpoint to any given segment and it is unique, only one. Because there is a theorem that there exists a midpoint to the segment. There is a theorem which can be proved. But right now, कोणीतरी विचारू शकतो ना, सर तुम्ही स्टेटमेंट लिहिले याचे काय आपण पूर्वी बोललोच नाही, हा शब्द पूर्वी बोललेलोच नाही गेल्या 4 लेक्चर मध्ये, कुठं काढला तुम्ही मिड पॉइंट म्हणून बरोबर. त्यामुळे आपल्याला मिड पॉइंट डिफाइन करायला लागेल. व्हॉट डू वी मीन बाय मिड पॉइंट अँड वी हॅव टू प्रूव्ह दॅट इट एक्झिस्ट अँड इट इज युनिक. करेक्ट, अगदी बरोबर. सो जॉइन एम So we can call this as construction. Consider ABM corresponds with ACM. 1. AB is equal to S E1 2 BM equal to CM.
M is the midpoint.
Construction. C3. Normally in this kind of problems, there are 2 things out of 3 are easily available or given or visible. And the third thing is required to be reduced or searched, find out. Okay, so now only this information is given. A B is equal to AC, and we are asked to find out B is equal to C. So we constructed and created one more situation where BM is equal to C. 2 things are there with us. The third thing is which is visible here is AM is equal to A, because AM and AM they are going to be congruent. Let me just write congruency because they are comparing the pictures. Common side. So these are the 3 reasons why I am writing that the required 3 conditions are satisfied now. Therefore, triangle ABM is congruent with the triangle BCM.
Yes.
This is most important. What we are going to write here, or student, the entire mark, suppose this is 5-mark question, we will just, while correcting, we will check what he has written here. If he has written This is the proof it has written SSS.
Three sides are given, so yes, necessity.
Then the test is correct. And then these two triangles now are congruent. Therefore, converse side definition if we use, we get.
Then the remaining
मॅडम
angles are
माईक बंद करा. माईक बंद करा आणि कॅमेरा चालू करा. दोघही जण तुम्ही जे बोलताय ते दोन्ही गोष्टी उलट्या आहेत. ते सर पण जेव्हा डाऊट विचारायचं तेव्हा मी बघतो म्हणून कॅमेरा चालू करतो. असं बरोबर नाही. कॅमेरा कंटिन्युअस चालू पाहिजे. ओके एनिवे काय झालं आता therefore given all the angles corresponding angles are equal, therefore angle B congruent angle C by CACD. This is what is required. However, additionally we have this angle is also equal to this. We have this angle is also equal to this, which we are not using, but it is available. It is the deduction. So only actually in the problem only one thing is given, AB is equal to AC. And we have reduced so much of information along by using that given information. This is fun in maths. You are given little bit, and because of the logic, you are deducing so many things simultaneously. Okay, and therefore opposite angles of congruent sides in a triangle are congruent. Opposite angles to the congruent sides of triangle are congruent. Yes, question.
Sir, angle B and angle C are congruent are given in question.
Angle B is congruent to angle C in the. No, given nahi hai na. If AB is equal to AC, then prove that angle B is equal to angle C.
हाँ sir.
CAC and CAC, that is standard.
Oh, international standard. CSCT and CSCT. This is one proof one of the same theory. Now can we have one more proof? Same thing can be done by some other way, some other method, some other route. We can do it by
Sir,
yes.
Sir, AB given that AB is equal to AC, so the angle opposite to AC is B, and the angle opposite to AB is C. Therefore, both are same.
But then, because this question is true, B is equal to C.
Yes. And
how do we
side
know that?
AC is equal to side AB is equal to AC. So the
Yes.
angle opposite to AB is C,
Yes.
and the angle opposite to AC is B. Therefore, angle B is equal to angle C.
That is what we are questioning. Now, what we are saying is a question. Is angle B equal to angle C?
Yes.
कॅमेरा ते वापरले की इज ऑब्वियस दोन साइडच्या समोरचे अँगल समोर इक्वलच असणार. सो जर दोन साइडच्या समोरचे अँगल इक्वल असतील तर हे बरोबर आहे. दॅट इज व्हॉट दे आर सेइंग. है ना?
They are supposed to be the same.
So we are questioning that the obvious statement which is available in the book is true or false, and we have proved that it is true. बोला तेजस्वी मॅडम बोला.
Sir, instead of taking midpoint, we can draw perpendicular from the point A to the side BC.
Yes. So there is one proof by which you can draw perpendicular the triangle ABC, and from A B C draw perpendicular.
From point A to BC.
So draw perpendicular from A to BC. It's going to be 90 degree perpendicular, and they let this point be M. So what will happen?
Now we will get one angle AMB equals to angle AMC. AM is common and AB equal to AC.
Therefore, by which test?
RHS.
Correct. Correct. RHS, because this is SSA situation. The only problem in this proof, I mean, it is correct. The only problem that those who have learned more mathematics than what we are learning now will ask you. नहीं, ऐसा सिंगल असणार नहीं. But then they will ask you a question that your idea of dropping perpendicular from A onto segment BC is good, but how do you achieve? Suppose that perpendicular what I am drawing from A on BC goes like this. Then there is no intersection. Which two triangles will you consider for congruency? Which angle, etc. Difficult. So this proof is dependent on this diagram, and we assume that this diagram is correct. That if that angle A, if you draw perpendicular from A, hopefully it will intersect B, ABC, and that point eventually will be midpoint also. The angles are going to be 90-90. So if our proof is going to be dependent on that, then we will be in trouble. But there is a way out. Okay, I mean, what is the way out? I mean, draw line BC, doesn't matter. Let the perpendicular from A intersect line BC. Of course, it will intersect line BC because line is partitioning this plane in three parts: upper half, lower half, and the line itself. So if your point is in one half, and if you are dropping perpendicular onto the line, somewhere or the other it will intersect. So let that point be F, and then you complete your proof, and you drop perpendicular. Therefore, this angle is 90, and this angle is also 90 because you have dropped perpendicular. Okay, it will not look good, and you will not be convinced that you have actually proved it, but that proof is going to be correct. It is not really going to be dependent. So you don't draw diagram, you write the proof.
Sir,
Proof is going to be correct.
Sir, for what angle of A, this will the perpendicular will go outside the line BC?
I don't know. I'm just asking if I draw perpendicular and if it doesn't fall on BC, then what will happen?
Sir, angle bisector.
Obtuse triangle. Sorry.
Now we are discussing perpendicular bisector proof. We have drawn perpendicular bisector. So if perpendicular bisector is drawn, if that point is within BC, then two right angle triangles are formed. Therefore, by RHS instead of SSS, we will end up our proof with RHS. Correct? But then there is a small technical difficulty. Here, the way I explained, there exists a midpoint, so you cannot ask me a question. How can I find this point M? And is it going to be between B and C? Yes. It is going to be between
Sir?
B and C. Yes.
In isosceles triangle, it is possible that the perpendicular drawn from the vertex of equal sides, it go outside the triangle.
Yes, sir. It
Is
is
it
always
possible?
be. It is
We don't know.
always
Suppose
be.
it goes, then what?
The rule of the symmetry, it will be passing through the between the B and C, na?
It will always be on the line, sir.
I don't know what is the rule of symmetry.
It will not go outside BC, sir.
Yes.
Sir, it will not go out.
Wishful, yes. Wishful thinking, but somebody can ask you to
Not
show.
wishful thinking, sir.
Not wishful thinking. Then leave it. Okay, what you are saying is correct. It will go. It will pass through.
No, angle A has to be acute angle.
Now also it will have to be.
It will always be acute.
I'm not deliberating. I'm not discussing. I'm just telling you the flaw in this proof. I mean, it is very advanced flaw. Nobody can pinpoint this flaw in this proof, but it is there. The way in this proof also, if somebody asks, is there a midpoint? Suppose we don't find midpoint, then what will you do? Yes, correct. Therefore, I have to go back and prove that every segment has a midpoint. Correct? Acceptable. Now, next proof is going to be angle bisector. You have an isosceles triangle, you draw angle bisector. Then, again, the same story. Oh, and we are not getting into that detail. If you are drawing angle bisector, might as well it will intersect. But there is a theorem, crossbar theorem, which is proved in the book. That if you have an angle and if you are drawing any ray in the interior of that angle, then it is supposed to cross the bar somewhere or the other. The angle bisector is the interior angle bisector. You are drawing another ray, then it is going to cross this bar. So cross bar theorem. There is a theorem which will ensure that your angle bisector will not run away like this. It will definitely intersect D and C internally, and then we can call this as M. This A. This angle is equal to this angle by design, by construction. AM is common. This side is given. So this proof is by SAS. SAS. This is the third proof of the same theorem. Lot of learning value. We are not learning something new, but we are doing the same thing by different methods. That adds to your problem solving ability. And let me give you more proof, which will not involve any of these complications. It is going to be absolutely simple, no questions asked. Consider ABC with ACB. I'm not drawing any additional statement. I'm just considering a triangle ABC with ACB. They are two different things. ABC is different than ACB. Okay, so what is given to be AB congruent to AC. So AB first two letters of first triangle congruent to first two letters of the second triangle. Okay, BC is congruent to CB. Yeah. Right? Whether you call the segment BC or CB doesn't matter, it is the same segment. And then AC of first triangle is congruent to AB of second. This is given. This implies that triangle ABC is congruent to triangle ACB by all three sides. SSS.
Yes.
Which implies major angle B is equal to major angle by CAC. We can always compare two triangles, one in one orientation, another in another orientation, and use congruency to prove. There is
So
no
we are
addition.
talking about,
Yes.
are we talking about the equilateral triangle?
No, it's okay. That's
So is it like watching in the
But-
week on screen and here, let's say my wife is watching from the other side. They're watching looking at the same time.
yes.
But ultimately here we are proving that all sides are congruent.
We are not moving our sides. BC is congruent to BC only, na? BC is not congruent to anybody else. Self-congruent.
The result is equilateral.
No, it's not. It's isosceles only. Consider ABC corresponds to AC. Corresponds to. Take get this? I mean, this is elegant proof. No confusion, no additional dropping perpendicular going outside, nothing. Within the triangle itself, everything is done. Actually, you can use one angle also. A is congruent with A because it is same. BAC is congruent with CAB. So you can use SAS also for the same. So it is a quick proof where BC is congruent to BC is not the statement. We say BAC is congruent to CAB. In that correspondence, proper. BAC is congruent to CAB. So it will be SAS, test of congruence, but the concept is exactly the same. Okay. So now I give you a chance to prove congruence. This is dependent theorem. If in triangle ABC or maybe in triangle ABC, if angle B is congruent to angle C, then AB is equal to AC. Congruence. चलो मिला डिसाइड प्रूफ एकदम कमी लाइन्स नाही जास्ती लाइन्स प्रत्येकाला you have to write the reason why it is true, and that is why I have demonstrated how the proof needs to be written. You are supposed to check the proof of students, and it has got 5 lines and one consideration. So 6 lines of proof, nothing less, nothing more. Maybe you can write 1, 2, 3, 4 and like it. Reasoning for every step is important, and the test of congruence is most important.
प्रूफ दाखवायचंय का सर तुम्हाला?
नाही वाचता नाही ना.
एक्सक्यूज मी सर सांगायचंय का
SAS
टेस्टचं नाव सांगायचं
prove करू शकतो.
नाही थांबा थोडा वेळ आपण फाइंड आउट करू.
Done, sir.
Yes. Now, more or less what we have done for the original theorem will be done similarly for the converse. If this proof is also going to work similar, only thing is that we are using AB is equal to AC 2 times here, we have to use angle B is equal to angle C 2 times. In this proof, last proof also will work and all the earlier proofs also will work provided we are using correct congruency test. Yes or no? सगळ्यांना जमले का?
मिड पॉइंट को ज्वाइन करने से नहीं होगा ना सर?
सगळ्यांनी येणार प्रत्येकाने येणार नाही फाइव डिफरंट वेज ऑफ डुईंग कन्वर्स ऑल्सो. गुड. सगळ्यांना जमले का? तुम्हाला डाऊट असला तर एक प्रूफ लिहून दाखवतो.
सर मेडियन काढली चालेल का?
काय
मेडियन फ्रॉम पॉइंट
मीडियन
ए.
काढले तरी चालेल ना. बघूया ना आता मीडियन नाही येईल का? Angle B is given to be equal to this is equal to this. Let there be midpoint M. Yes. Side. Angle थोड़ा त्रास होईल बघ. This is equal to this. SS A situation होती ना. And you don't know whether this angle is equal or not. 90 वाला. So that you can apply RHS. Difficult. So midpoint ने थोड़ा tough जाईल. कारण SS येते.
पर मिड पॉइंट तो
कॉन्वर्स ऑफ आइसोसेलेस ट्रायंगल थ्योरम.
हाँ
assumption AB is not equal to AC.
हाँ
Sir, angle
Contradiction.
bisector नहीं होऊन जाईल.
Contradiction.
By drawing perpendicular, sir?
Sir,
Yes,
by
you will get
sir with angle bisector it will be easier also.
angle bisector you will get.
By drawing perpendicular?
You will get.
And by indirect proof. Assumption.
पण अजून सगळे ना थोडे लहान आहेत अजून त्यामुळे आपण जरा पुढच्या गोष्टी आपण नको बोलायला.
बस.
Sir, we can apply side angle.
Side angle काय?
We can apply side angle also, sir. If we draw a perpendicular line, RHS and side angle also will be applicable. Both.
If you draw perpendicular, then RHS will not be useful. It is side angle only. If you draw perpendicular. If you draw angle bisector, then it is angle side angle ASA. बरोबर? If you try to do it in the fourth proof way, then it will be ASA.
Yes, sir, self congruence.
Hmm. सांगू का? Let AM be angle bisector of A. Triangle ABM. Triangle ABM corresponds with ACM. AB equal to this. D.
Sir, you have to
Will
prove
be
AB is equal.
angle C.
Sir, you have to prove AB is equal to.
Sorry. Mistake. Angle B is congruent to angle C. B1. AM equal to A is congruent to A. Set. आणि कोणाचा बायसेक्टर काढले ना म्हणजे BAM congruent to angle CAM at construction. म्हणजे दोन अँगल आणि एक साइड मिळाली SAA. BM congruent to ACM by and therefore AB is equal to S, right?
Sir, we can also do it by saying angle AMB equals to angle AMC.
Right? We can say also.
Angle AMB equals to angle AMC.
No, but you have drawn bisector. Huh? You don't know whether this angle
No,
is.
no, but we know because we have drawn bisector for angle A. We know
Yes.
angle B equals to angle C. So 180 minus, I mean, the sum of those both angles equals to same. So angle M in both the cases will be same.
Yes, but then additional work. Huh? 180 degree we have to bring and write separately that AMB is equal to 180 minus O plus X. AMC also 180 minus O plus X. Therefore, AMB is equal to AMC. And angles are also. Yes, can be done, but little long. So you will realize that these are really easy proofs, easy problems, and can be done by more than one methods. Therefore, but very good learning method. Okay, now having done this,
Sir,
yes,
तर ASA नी कसं प्रूव्ह करायचं सांगू शकाल?
right. ASA.
Angle B is equal to angle C and BC segment BC is equal to BC.
ASA. Correct, huh? Triangle ABC corresponds with CP. This we have to show. Angle B congruent to angle C. BC congruent to CB. And angle C congruent to angle B. Given common. Therefore, these two triangles are ASA. बरोबर आहे समजलं? Yes. Actually, A can be. Then
So by drawing the perpendicular, we can
fifth row. हाँ.
perpendicular draw करके भी तो हम उसको एंगल साइड एंगल लगा सकते हैं.
Perpendicular draw करेंगे तो एंगल AAS.
By drawing perpendicular, we can prove that it is congruent by AAA.
A is not the test.
A is not the congruency criteria.
SAA. By perpendicular also it will be SAA. because you are getting one more information about angle. You already have one information about angle, and there is a common side. So again, it is going to be SAA only, even if you draw perpendicular.
So we cannot take it as BC is equal to CB in the earlier proof,
BC is equal to CB. Yes, we can take. Why not?
because that is what we have need to prove.
No, we are supposed to do AC is equal to AB, and we are taking BC is equal to CB, which is correct. Okay. Okay. Let us pyramid by way. Do that. Equilateral triangle is equiangular triangle. If all the three sides are equal, that is what we will call it as equilateral. If we have equilateral triangle, then all the angles are going to be equal. Each angle will be 60, 60, 60.
सर SSS ने सेल्फ कॉन्ग्रुएंस आणि होऊ शकेल ना
तुम्ही 6 स्टेप मला प्रूफ लिहा. असं एकदम त्याला कचऱ्यात काढू नका SSS.
Excuse me, sir.
Yes.
Sir, in earlier proof, what you want to prove, I couldn't understand. Can you please explain it again? In the earlier proof, sir, that is triangle ABC is congruent to triangle. Means you wrote that ACB like that. That's sir. That proof I couldn't understand. Yes, below that diagram, sir. Yes, this.
This one. Yeah, this one.
No, that I understood, sir. That white below the diagram, sir.
Have you understood this?
Yes, sir. Yes. This one also.
Which one you did not understand?
Oh, this one only. Just a minute, sir. Means why we are trying to prove that the same triangle is congruent to with that means ABC is congruent to ACB. Why like that, sir?
Because we want to prove that angle B is equal to angle C. You write down this proof, it is there in the notes also. You spend a good amount of time on it. You will understand.
Okay, sir. Okay, sir.
Yes. Can we prove? Equilateral is equiangular and equiangular is equilateral after this. Why equilateral triangle is equiangular?
Sir,
Perpendicular drawn.
in triangle. Sir, may I?
Wait. I will tell you when to disclose the answer. Till then, hold on. Try to prove it by one more method.
Sir, can we use the matter?
Yes, tell.
In equilateral triangle, all sides are equal.
Yes,
First, we will use AB is equal to AC. Therefore, opposite angles to the equal sides are equal. Therefore, angle B is equal to angle C.
correct,
Secondly, we will take side BA is equal to side BC. Therefore,
correct,
their opposite angles are equal. Therefore, angle C is equal to angle A.
correct, very good.
From these two statements, we can say that angle B is equal to angle A is equal to angle C.
Correct. P1, AB
AB
is
is equal to AC
C equal to
is
C.
equal to C.
In triangle ABC, BC implies angle C
Angles is equal to angle B.
B by previously used theorem. So we make use of what we have done just now instead of going back to congruency every time. We have just proved if two sides of a triangle are equal, which is the case here, therefore opposite angles are equal. Again, in triangle ABC, if we write BC is congruent to CA, then we get angle A is congruent to angle B. Or same reason. We call this statement as Roman 1 and Roman 2, then Roman 1 and Roman 2 imply angle A congruent to angle B, congruent to angle C. Hence, AB च्या opposite C, BC च्या opposite A. And by using converse, we can prove that every
है ना क्या कर रहे हो
triangle
क्या किस जैसे सर जो करा रहे हैं वो करो ना उल्टा पुल्टा कुछ भी क्यों कर रहे हैं नहीं गंदा नहीं बनाया अच्छा बनाया हमने जो पर
can prove this also exactly. So congruency is a very, very powerful tool in geometry. Okay, using this, whatever we have done today, we will solve few problems and discuss some more theory next lecture. Choose same link every Tuesday, Thursday, same time, 7 to 9. Today we have 52 now and 18 in the class. 70.
In the class, we have done that problem earlier, that isosceles triangle. But while we solve this, means in this sequence, can be that
Yes, if we complete 1 year of our study, then we are free to use any theorem anywhere because we have learned it in that sequence. है ना? म्हणून in this class we cannot use the theorem which we have not proved to prove earlier theorem. That discipline we have to follow. But once the complete geometry is done, and if you get a new problem, you can use any theorem because everything is proved. Everything is available. Okay. Thank you. That is where we stop for the day.
Sir, I have doubts in GCD PDF.
Yeah,
that is
we will discuss it at appropriate time. We will have a lot of free time in the end. We will discuss. Or you can start discussing on WhatsApp group. You can start asking your questions, and there will be somebody who will answer them. And if there are few questions unanswered, then we will see how to solve them in the end.
Okay, sir.
But that WhatsApp group can be used for discussion.
Okay, sir.
Thank you. Ending the meeting.
Thank you, sir.
Thank you, sir.